Hey guys, it's Riley. I have the 2013 FRQ, which is going to be number 5 in your packet. Okay, a particle moves along a straight line. For t is 0 to 5, the velocity of the particle is given by the following expression. And the position of the particle is given by s of t. It is known that s of 0, or the original position, is 10. A. Find all values of t in the interval 2 to 4 for which the speed of the particle is 2. So to do that, speed is obviously the absolute value of velocity. And so you're going to have to set your velocity expression here in absolute value bars equal to 2 and solve. But the problem with that is your solve feature will cause it to spin for a ridiculous amount of time, so you're going to want to graph it. And to do that, you'll have to subtract 2 onto the same side as the absolute value bars. And so I've done that here already. And here we go. And I'm going to graph it. This is the zoomed in version of the graph. And because we're going to want to go from 2 to 4, we're looking at these two right here. And so you're going to hit your F5 button and then you use your 0 function. Okay. And then your lower bound will be the left bound actually. Okay. And then upper bound. And your first 0 is going to be 3.12763, or you can round it to 3.128 like I did right there. Okay, and then you're going to have to do it again. So hit your f of 5 again, hit your 0 function again. You're going to go just underneath the axis and just above. And then your next 0 is at 3.4734. which I made 3.473 as your shorter version. That's A. Okay, B. Write an expression involving an integral that gives the position s of t. Use this expression to find the position of the particle at the time t equals 5. So, we know that our initial position at s of 0 is 10, so you're going to have to add 10. And s of t is going to be given by taking the integral of your velocity. So the expression, the basic expression would be 10 plus the integral from 0 to t of velocity dx. And then you sub in 5, and then when you solve that on your calculator, let's see, is that gonna, there you go, focus. Let's go to our home. And then I've done that here for us already. So you plug in 5 and you're going to get negative 9.20733. And that's B. Okay, C. Find all times t in the interval 0 to 5 at which the particle changes direction. Justify your answer. Okay, so we know the particle changes direction when your velocity changes sign, and your v of t equals 0 when t equals 0.536033 and when t equals 3.317756. And you're going to do that by graphing again, and so we're going to have to go back to your y equals and make this, like, take out the absolute value bars. So I'm just going to go in and delete that and then delete the 2 that you moved over. Give me a moment to do that. Okay, delete. And that'll give you your raw velocity expression. You're going to graph that. And this is the same zoomed in version, except the graph is a little bit altered, obviously. And then you're going to solve for your zeros again the same way. So f of 5, 0 function. I have to hit the button a bunch of times because when you hold it down, it doesn't work. Okay, lower bound, upper bound. Your 0 is, as I said before, 0.536033. You're going to repeat the same process. You know the drill. Okay. And 3.31776. Okay, cool. And then I also used a sign chart to help verify what I'm doing here. And then, so if we're going to fix our zoom so that it goes to the whole function again, so you guys can get a better picture of this. So I'm going to hit F2 and then zoom standard, which is zoom 6. Let it draw itself. Okay, you can see here at the 0.536033 right there, it goes from negative to positive. So I showed that here on the sign chart, negative to positive. And then again, at the 3.31775661, it goes from positive to negative. You can see that here in the sign chart, positive to negative. So, because the particle changes direction at the time 0.536 and at the time 3.318, we know that it does that because it changes sign from negative to positive in this case and from positive to negative in that case. Okay, so that's C. Last section. D. Is the speed of the particle increasing or decreasing at time t equals 4? Give reason for your answer. Okay. Well, if you plug in 4 to your original velocity expression, you're going to end up getting negative 11.475758, which is obviously less than 0. I use my calculator for this because I'm lazy. And then your acceleration is going to be the derivative of your velocity expression, and that's going to end up being negative 22.295714, which is obviously also less than 0. Because the velocity and the acceleration have the same sign, the speed is increasing at time t equals 4. Therefore, you are done. Enjoy yourselves.